as the introduction says, we have various techniques already existing in today's time, but the problem lies in what type of expression it is. Basically, seven main data sets which are classified till now, like happy, sad, surprise, and so on, basic emotions. But you can also have a mixture of these emotions which are available on someone's face. So therefore this project focuses on the various classical machine learning methodology and deep learning methodology, and then we compare which one is the best of all. There are various applications for the same, like you can have in medical diagnosis where a person might appear to be happy but inside he is feeling sad, so various emotions need to be recognized, and you can see the list given here. And also I believe that when we are dealing with machine learning and the self-driving car, I believe that robots can also benefit from this system, because if they can predict the human emotions, they can also react as per the behavior and the outside environment. And moving ahead, there are basic four algorithms which we have covered in our presentation for the face detection. They are listed in the slide. Without taking much of the time, I'll be explaining I'll be explaining the basic of this detection method. What happens is, first of all, you have the facial detection. There are various objects in the surrounding. So it can be any object, be the vehicle, be the animal, or the person, as we stated in the previous presentation. So the system basically detects the face, first of all, of the human being only, and then after the face is identified, we move on to the expression analysis. What are the features of the face? It may be a male or a female. It may be someone who has wrinkles on face, but the expression is not much clear, or may appear as surprise because of the mouth and various, parameters. And then it identifies the face. As in various other minute details are compared to the data which is already fed in the system. And the general system goes like we pass image to the system for the classification. From there, it is pre-processed. Pre-processed as in whatever is the useless part in the whole image, that is removed to normalize the image. And then it classifies as in whether it is a face or not. And then the output is indicated to show how the image is looking like, which emotion it indicates. So the first algorithm is VIOLA-JONES algorithm. It actually, there's a window size, and the moving window which moves across the image, and every time the size is increased. Why it does so? So that the image can be normalized. And after setting to the maximum size, we stop the procedure. Otherwise it keeps on increasing, and the frequency and resolution, everything of the image is set. So then there comes the neural network based face detection. You must have researched about heard about CNN and then ANN. All these algorithms, they are already existing, but we need to find which one is the best. There is also a combination, like you see, this is based on the retina of a person, and ANN is already with the Gabor wavelet and PCA. So these are various algorithms. Depending on their performance, we find that the CNN is the best detection rate, as you can see in this analysis. And moving ahead, this support vector machine. What happens in this is that support vector, as the name indicates, it is adapted to the face recognition by modifying the interpretation of the output of the SVM machine which is available. And then these earlier, like the traditional SVMs used to return a binary value, and but in today's time, to train this algorithm, what we do is we explicitly capture various facial images as indicated here. Then different facial images are compared from the traditional or what is already present in the system, and then we find the expression. Then SMQT features in snow classifier. This is not something which is used much, but just to explain, this is based on the pixel value. What happens is the image is using color luminance or the chrominance based on SMQT features, and then it detects a face uniform and non-uniform background color, and accordingly it identifies the expression. Then yes sir. So I'm sorry, but I'm not aware of the full form. Yeah, so now that was the first part of identifying the face. Now comes the extraction of features. Till now there have been three features or techniques used, which are geometric or feature based techniques, appearance holistic methods, and hybrid techniques. Hybrid is again the mixture of these two, as the name indicates. Why we need to extract the feature? It is mainly to perform to compare the efficiency and improve, so that we can improve the system for the next time. And the geometric feature, there is active appearance model already existing, and it tracks the points or the facial points, and it makes it a dense set, so that the set can be used to compare the expression. We'll show some images later on. And then we have holistic methods. It does not treat, like as a line says, the face as individual part, but whole face, the whole person's image is compared. And the most popular algorithm which exists in this method is the Gabor wavelet. It has been surveyed that this produces the best results in recognizing the expression. But again, because of the time complexity and the memory storage power, it is not usually preferred. Therefore, we go for the local binary patterns. Local binary patterns are classified into real parameters and binary parameters, as you can see in this slide. So various parameters like eyebrow raised distance. So what does eyebrow raised distance? How much is the eyebrow raised? Accordingly, it will recognize whether it is a surprise or a sad emotion. And similarly, you will have various other parameters. You can go through the slide. I'll be uploading in the group. And now same goes for the binary pattern. Binary, as the name suggests, it will either indicate presence or absence of a particular parameter. Now my project partner will be explaining about the deep learning based approach.
So using the classical machine learning algorithms, we need to take care of the feature extraction part that will reduce accuracy for our model a little bit, not at all, little bit, a lot. So approaching, so if you want to apply in a real-time scenario, we need a better model. So we go for a deep learning based approaches. It uses the convolutional neural network to solve this problem. Many of the algorithms are based on VGG net, AlexNet, SNet, like Google Net, like that. So next slide, please. Okay, and I'm going to talk about first one is RBMT model. So I don't have the much more details because this was the first Kaggle competition winner. There was a data set available in the Kaggle website. FES 2013, and this model was the winner of that competition. And you can see here there is an input layer, and the last one is a fully connected layer with 7 nodes, and intermediate layers include the convolution, max pooling, like that. And next slide, please. And this model can give about 71% of accuracy. And the next model is a VGG based model. So here also you can see that it works like the convolution and max pooling, like that. So in this model you can see that they have tested with various models with BK VGG 8, BK VGG 10, BK VGG 12, BK VGG 4, like that. It's only depend on the number of layers that we are using. And next slide. And BK VGG 12 model gives an accuracy of 71%. In this case, if you are there are so many data sets are available for this problem, but if you are still suffering from the lack of data sets, we can use data augmentation techniques. And before we doing all these steps, we need to make our our image should be better. That is, it has to work in the daytime and nighttime. So we need to add a filter in the first stage itself. Then we need to detect our face. Then we need to we need to classify it, whether which emotion is present in that, which expressions are there. So data augmentation can be used can also be used if we are lack of data sets. And in pre-processing stages, we can use histogram equalization as well. Next slide. Okay, then hybrid texting for human emotion detection, which is used ideally with the neural network. And this one gives around 90% accuracy on JFFE dataset. But the problem is it is too much complex to implement. There is no much already implemented repos are available. So working on that will be a little bit difficult. And but it can give around 90% of accuracy. The next slide.
Last slide bana hai.
Yeah, and next one is a kernel PCA. Kernel PCA based. This is also gives a 91% accuracy, but in this case we are also taking care of PCA. I mean some of the other techniques like PCA is kernel PCA is applied, so which gives a 91% of accuracy. And face detection can be done with many proposed algorithms. One we have seen is CNN based approach using VIOLA, which gives a 91%. We all know about the VIOLA algorithm, so discussing about that is not required, I think. And another one is a combination of CNN and SVM, which gives a 98% of accuracy. I think VIOLA based algorithms are widely used, and many repos are available for that. I think the other one can be used in the case of face detection. And we didn't see any kind of combined approach like doing everything at one step, detecting the face and expression detection at the same time. So every algorithm works like, so first we needed to localize, that is regional interest should be fine, then we need to classify that. So and only one paper shows us are available that shows the combined approach, but its accuracy is very less, around 20 to 30%, like that. So we prefer doing it as a separate box. So these are our references given in the